Thanks to the moderator. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thanks for joining my presentation. My name is Syiah. I'm so excited today to present our research about multi-classes emotion detection for unbalanced Indonesian tweet. For this research, I collaborate with Professor Chen Ishin from National Tsinghua University in Taiwan and with Ali Misbollah from Kuala University. Ladies and gentlemen, have you ever posted your feeling on Twitter using a hashtag of your emotion? Maybe when you are pleased about what's new coming in your life or when you are upset about a situation. Actually, a lot of people do that. When you use a hashtag to show your emotion, that's helpful for a data scientist to collect your tweet based on the emotion. Then make a model to automatically detect an emotion of other new tweets even for the tweet without containing any hashtag. That's what we have done for Indonesian language. Automatically detect emotion on Twitter can be applied in many applications, such as to see how citizens react to a presidential candidate, how people react to an event, and listening to customer feeling about a product. We use 8 emotion classes from Patrick Will Basic Emotion, which are already very popular. We start our work by crawling dataset from Twitter by using hashtags that represent the emotion of user. Then we group each hashtag tweet into the emotion classes, like we have the hashtag of happy, proud, and thanks God belong to joy emotion. And also we do for all of the emotion classes. We experiment with the Indonesian language, but in this presentation, I give all the example in English to make sure everybody understand the idea. We are interested in adopting the idea from a successful work proposed by Argueta et al. Called unsupervised graph-based pattern extraction. This method has applied and shown a good performance in Western language for English, Spanish, and French. We want to apply this method for the Indonesian language and we will enhance the performance. Their idea is, like we see on the picture. First, we already have hashtag tweet corpus that we crawl based on the hashtag emotion. From the hashtag tweet corpus, we build the first graph, which is hashtag tweet graph. Then we also crawl the news tweet from the official account of newspaper. From the news corpus, we build the second graph that we call news graph. Since the content of the first graph is more subjective than the content of the second graph, then we reduce the first graph by normalizing them with the second graph to obtain a robust graph that we call emotion graph. Here I give the illustration. For the hashtag tweet graph, we have what the weird country, I hate the demo, and for the news graph, we have president prevent demo in the country that look neutral and objective. After we normalize them, in the end, we have the emotion graph, which have very strong emotion like what the weird, I hate the. Based on the emotion graph, we construct pattern by combining 2 and 3 words. Then we replace a word with a wildcard. The wildcards are used for term generalization, which help deal with data sparseness in a small corpus. Then we calculate the frequency and only choose 10,000 highest frequency pattern to build the model. For each of 8 emotion classes, they have 10,000 the same pattern, just in different order. We rank the pattern based on these 3 criteria. I believe everybody here already familiar with this term. The first is term frequency, which means the number of patterns in an emotion. The second is the inverse document frequency, which means the pattern is common or rare across all emotion collection. And the third is diversity, which means the number of unique words that can be captured through wildcard. For example, we have a tweet, oh my god, suppose from this tweet we have two matching patterns, O wildcard and wildcard god. Based on this pattern ranking, Joy has score of 10 and for surprise has a score of 5 because the smaller one is the winner, so tweet oh my god is detected as a surprise emotion. Here is the performance. Based on the precision, we can see for some class like fear, surprise, and disgust, their performance were not satisfied. It was caused by the unbalanced distribution of tweets that were crawled by hashtag. We have a lot of tweets of joy, sadness, and anticipation, but very few number for some other classes, especially for fear, surprise, and disgust. Let's see the condition of testing tweet. We crawl this testing tweet without using any hashtag, and the number of tweets come naturally unbalanced too. Each tweet is allowed to belong to one or two or three emotions, so it was allowed as multi-classes, with the average of label is 1.6. We were still curious about what made Indonesian tweets suffer unbalanced condition. Then we asked another native Indonesian person to relabel our testing tweet. The result, like we can see here, for some emotions, especially fear and surprise, are inconsistent. We can say fear and surprise emotion are not strongly expressed in Indonesian language. So we think it also affects the poor performance for minority classes. From these two pictures, we can see the effect of emotion consistency to precision and the effect of twist number to precision is quite balanced. Both consistency and twist number has positive correlation with the precision score. From this chart, we are able to see the correlation among precision, consistency, and number of tweets. Look at the anger. Even we got very small data tweet, but the performance is good enough because the consistency of anger emotion is high. So, how to solve the unbalanced condition for our case? Many previous work focus on training set to solve the unbalance, such as they will do oversampling for minority class. But remember, we don't have training to it that already have the label. We play on the unsupervised one. We only have pattern rank for each class, so we will use that to solve the unbalance problem. Why minority classes have low performance? Because patterns are not ranked well for minority classes. It will produce misclassification. The idea is we re-rank the pattern for minority classes to get an appropriate ranking of pattern. We will adjust pattern weight, especially for fear, surprise, and disgust, by using variable XYZ to change the value of TF, IDF, and diversity. I will show you how we do for fear. For each variable XYZ, we change their value independently from 0 to 10 as we see on the axis label, because we don't know from which value we will start. Then we will pay attention to the curve. Is that possible to going up again? If done, we can stop here. Then for the highest precision for each variable, we take the constraint to build other XYZ value based on the constraint. Then we will run it again for the value of XYZ. This is a simple math, but we love to link a simple thing to solve our real problem. And now, because we have two of highest precision, we do a second iteration. Take the constraint to build a new value for variable XYZ. And finally, we got one highest precision as final weighting value. The precision is increased by 21% for fear after adjusting pattern weight. Then we do the same way For surprise and gain, 23% precision increase. And the last we do for Disgust, the precision increase by 14%. These are variables we gain for the best whiting. Y is always higher than others. That means the inverse document frequency is the most important criterion from ranking of the minority classes. That makes a lot of sense, since the inverse document frequency can make the rating appear more substantial. But for the majority classes, all of the criteria are important. Before, we adjust one by one and now together for all minority classes. The total improvement of precision system is 9%. There are three conclusions which we can summarize from our work. The first, Indonesian twist emotions suffer unbalanced condition. Second, adjusting pattern weight can significantly improve the precision of minority classes and the overall precision system. And the third, the most important criterion from improving precision for minority classes is the inverse document frequency. Thank you for your attention. Terima kasih. Syiah.